Good day everyone, and welcome to the third video in a series observing and exploring the continuity and differentiability of various functions such as the polynomial function. In the second video, we illustrated and explained that the ordered pairs 1, f of 1 and 1, f prime of 1, for example, mean when observing a given polynomial function f of x and its derivative function after creating a GeoGebra construction with those elements. In this video, we will illustrate and orchestrate artistically the visual representation of the limit definition of the right-hand derivative and left-hand derivative, referencing an online resource. Let's do this one. And demonstrating how to reconstruct a GeoGebra applet that I have created, which can be used by each basic calculus learner in their navigation of limit and derivative concepts. In this GeoGebra applet, so we have the applet itself. So we have secant lines and then approaching into a tangent line. We also have a section for the components of the GeoGebra applet to be reconstructed. And of course, we have the interactive, explorative activity objectives, right? So we are itemizing the activity objectives. So please feel free to go through the objectives. Then we have the section for the instructions for such interactive explorative activity prior to the answering of the multiple choice questions as a guide in mastering the knowledge and skills one can gain for the said limit and derivative concepts. First, we define the polynomial function. So we type x squared plus 3x plus 2. Next, we create a point by typing a is equal to 1, f of 1. This is the point at x equal to 1, which shall serve as a center point for evaluating the right-hand derivative and the left-hand derivative. So we type a is equal to 1, f of 1. Next, we're going to add a slider h with a minimum value of 0.001 and maximum value of 3. The minimum value of 0.001 is a value close to 0 because we're allowing h to approach 0. Okay, so our approaching value for the limit definition is h. And yes, h shall approach 0 without touching 0. We add a slider and h, and minimum value is 0.001, close to 0 but not touching 0, and the maximum value is 3. Next, we're going to have the terminal point. So we type b is equal to 1 plus h, f of 1 plus h. So again, this is the point to the right of x equal to 1, center point, where h is the distance between the x coordinates of the initial point and the terminal point, where the x coordinate of the terminal point is greater than 1. So we type b is equal to 1 plus h, f of 1 plus h. Next, we type the expression a is equal to f of 1 plus h minus f of 1. This expression is the numerator for the slope of the secant line, representing the difference in function values of the terminal point and the initial point. Type a is equal to f of 1 plus h minus f of 1. Next, we type the function g of x is equal to a over h. This is the slope function of the secant line. Just type g of x is equal to a over h. Then we're going to draw the secant line connecting points A and B. So we have point A and B, and then we're going to have a secant line. Next, we're going to type B is equal to limit g of x, comma h. The parameters of the limit functionality is the function itself and the approaching value. Our approaching value is h. So this is the right-hand derivative, being the limit of the slope of the secant line, where the terminal point's x value is to the right of 1, where such x value of the terminal point is greater than 1. So we type b is equal to limit, and then the parameter, we have the function and the approaching value, which is h. Next, we type c is equal to 1 minus h, comma f of 1 minus h. So this is the point to the left of the initial center point. This serves as a terminal point for the left-hand derivative illustration, where the x value or the x coordinate for such a terminal point is less than 1. So we type c is equal to 1 minus h, comma f of 1 minus h. Then we create a secant line connecting point C and A. So we have point C and A. So let's draw a secant line. Next, we type this expression. So we type c is equal to f of 1 minus h minus f of 1. This serves as the numerator for the slope of the secant line, representing the difference in function values between the terminal and initial points. So we type c is equal to f of 1 minus h minus f of 1. Next, we type g of x is equal to c over negative h. This is the slope function of the secant line for the left-hand derivative. Why is the denominator negative h? Or why is h a negative h? H is negative because point C is to the left of x equal to 1. So we type g of x is, or m of h. M of h is equal to c over negative h. Then we calculate the limit by typing the definition. D is equal to limit of m of x, comma h. So this is for the left-hand derivative, being the limit of the slope of the secant line where the terminal point's x value is to the left of 1. Hence, the x value of the terminal point is less than 1. So we're going to call the limit functionality. So limit, and then the parameter, our function for the left-hand derivative is m of x, and then our approaching value is h. Lastly, we create a tangent line using the tangent functionality. This display of the tangent line at x equal to 1 shall validate that the limit of the secant slope equals the tangent slope. Let's call the tangent functionality. Click here, then click tangent, then click on the center point or the initial point A, and then the polynomial graph. Now for the exploration part, let's move the slider h to the value 0.01. What did we notice? Yes, we have validated the limit definition of the right-hand derivative and left-hand derivative, being the limit of the secant line slope, which is equal to the slope of the tangent line at the initial point where x is equal to 1. For the second part of this exploration, you may add slider W. So just click on open an app and then add slider W with minimum value of 0. And then update the GeoGebra pane. So replace all instances of H with W in the algebra pane. Then next, adjust slider W. Move slider W towards 0 and observe the changes. Watch how the secant line changes as W approaches 0 and observe the effects on the calculation of the limits. Right, so let's add a slider W. And then we have 0 and then 3. And then we're going to change all of the instances here, the H variables here with W. So this is W, then this is W, so yes. W. Now let's move the slider W to the minimum value 0. So what did you notice to the limit calculations here? Yes, we will have question marks for the calculation of the limits for the right-hand derivative and left-hand derivative. Lastly, please check your understanding by answering all of the comprehension check questions in this applet. So thank you so much for joining me today, and I hope that you have learned something